Hi, everybody. So I am so sorry I cannot be with you today. I really would love to be there, but unfortunately, I have sick kids again, and my father-in-law he's kind of immunocompromised, so we can't really send our sick kids over to his house for babysitting. So unfortunately, I am home again with my sick kids. I'm not sick, but it's just my kids. So. But I plan on being back tomorrow. We got somebody to watch our kids tomorrow, just in case they're sick again. But I will hopefully be back tomorrow. I believe I will be back tomorrow, but is what it is. But you got a video, right? You got a video. All right. So let's take a look at section 2.5. If you don't have the guided notes already, please make sure you get it from the sub. I have the guided notes all printed out for you. Um, Remember that the quizzes. If you had not already taken your quiz and you'd like to, the sub does have them in the makeups folder. I'll leave them out for them. So if you do want to make that up, you can definitely do so. But right now, I'm just going to do this video over section 2.5. So if you would get your guided notes out, that would be greatly appreciated. So now what we're going to be looking at, and this is the last section within chapter 2. So just to kind of give you a heads up, we are doing for you guys, today is Thursday. We're going to be doing section 2.5. Friday is going to be review. So we'll be going over this homework assignment, asking any questions that we have. And then we get the weekend. And then on Monday, we're going to review again. And then on Tuesday, we have our chapter 2 test. Okay. So that's kind of a rundown of where we're headed the rest of this week and next week, basically. All right, so section 2.5, solving compound inequalities. Now, what is a compound inequality? A compound inequality is just basically an inequality using the word and or. I like to think about it this way. If I wanted to look at everybody in the class and I said I was going to gather up all of the kids that wore jeans or wore glasses, I'm going to gather up all the kids that are wearing jeans or wearing glasses. So I would look around the room and I would pull everybody. What if somebody's wearing jeans? Get them. What if somebody's wearing glasses? Get them. What if somebody's wearing jeans and glasses? Well, get them twice. I don't know. No, we don't get them twice, but that's what I'm getting at here. We're using an or statement. Okay, just an or statement. If I'm thinking about, if I want, any number less than 5 or bigger than 10. Okay, a number less than 5 or bigger than 10. Or doesn't mean I have to fit both of the two criteria. I just have to meet one of the two criteria. So that means I want a number less than 5. So maybe 4. Okay, 4 works. But 4 is not greater than 10. That's okay. It's just an or. You're just wearing jeans. You don't have to wear glasses too, right? It's just the or. Just talking about or. Now, what if I'd switched that around? What if I had said, okay, I only want people wearing jeans and glasses? Well, now that's a different story. Now they have to meet both of the two requirements. They cannot just be wearing jeans. They cannot just be wearing glasses. They have to be wearing jeans and glasses. That's a little bit more restrictive. When I use the term and, that's a little bit more restrictive. Okay? So if I wanted numbers bigger than 5 and less than 10, well, bigger than 5, 6. Okay. Is 6 less than 10? Yeah. Okay, good. Well, what about 15? 15 is bigger than 5, but is it less than 10? No. So we have to be a little bit more cautious when we use the term and. All right. So this is intentionally left blank. I want you to fill in the graph over here for each one of these. Think about this. All numbers, you don't have to worry about the real part, all numbers greater than 2 and less than 6. Greater than 2 and less than 6. If I wanted to plot them all on a number line, they would be filling in this over here. So go ahead and copy this down into your guided notes. This is the way we would write that inequality. It's a compound inequality using the word and. You don't actually see the word and. It's kind of tied into the notation there. We put the smaller number on the left side, the bigger number on the right side, and we use two less than symbols to show it. Okay, this is how it would look. If I wanted all numbers greater than or equal to 2 and less than or equal to 6, this is what it would look like. Now, what's the difference between these two? Oh, the filled in dots. So did the rule change at all? Or equal to's mean filled in dots? No, that rule did not change in the slightest. That rule remains the same. So let's talk about x is less than 2 or x is greater than 6. Okay, that means how would I graph this piece? X is greater than 6. Open circle, going to the right. How would I graph just this piece? Open circle, pointing to the left. Oh, so you mean to tell me it's just two inequalities on the same graph? Yeah, when I use the word or, it's a pretty simple graph. All you got to do is just graph both of them on the same number line, and then that's it. Same thing is true when I work with the or equal to's. That just fills in that dot at 2 and 6, okay? All right. Now, the formal math definition of an and inequality is called an intersection. It's called an intersection. An intersection just mathematically means it has to meet both of the two requirements. So take, for example, this sentence down here. That means if I say 0 is less than x is less than 10, that means I want all numbers in between 0 and 10. All numbers in between 0 and 10. Not equal to 0, not equal to 10, but all numbers in between. Okay, that means like 5. 5 is good because it's bigger than 0 and still less than 10. 6 is still good because it's greater than 0 and still less than 10. Is 17 still good? 17. Is that greater than 0? Yeah. But is that less than 10? No. So 17 does not work. It's got to meet both of the requirements. This is like the jeans and glasses type thing. Okay. Now, how do we solve those things? Now, when you've got a compound inequality and you want to solve it algebraically, man, life is good. You can kind of kill two birds with one stone. You ever hear that adage? Basically, what I'm looking at here is I subtract 1. And if I subtract 1 here, because that's all we would do to solve this inequality, think about it like this. How would I solve just that inequality? Well, I would subtract 1 here and then subtract 1 here, right? Well, what if I move that white box over here? What if I wanted to solve this one? Well, I would subtract 1 here and then I would subtract 1 here. So you mean to tell me I can solve them both at the same time? You mean to tell me we're getting a 2-for-1 deal? Yeah, folks. So you solve this, you get a -6 is less than x is less than 1. Every and inequality is kind of like a 2-for-1 deal. You're solving two inequalities at one. So how do I graph it? Well, think about where the endpoints are. Any and inequality is going to have a smaller end and a bigger end. You put the smaller and the bigger on there. This one I only need 2 points for. I have to figure out, okay, do I put an open circle at -6? Yep. Open circle at 1? Yep. There's no or equal to's. And this means I connect them in the middle. Every and will point in toward each other. Remember, ands go in toward each other. Ors will go out, and we'll talk about that in a second. Okay? Oh, you had a graph there for you. Oh, okay. You just number line your graph. Oh, right. I didn't realize there was a graph there. Okay, I think there's a graph for this one as well. All right, so how would I solve just one side of this inequality? Like if I did just ignored that less than or equal to 11, well, I would add 1 here. Remember, do our addition and subtraction. Well, if I add 1 to the middle, I've got to add 1 to both sides. Okay, 9, 3x, 12. All right, well, I would divide by 3 to get this to go away. Whatever I do to one piece, I got to do to the other. So 3x, 4. Okay, there's my and inequality. Again, you guys label your number line. I'm just going to do this real quick. All right. Open circle at 3 because there's no or equal to there. Closed circle at 4 because there are equal to's there. And now I put it in between them. Okay. All right, let's take a look here. Now, the mathematical, this is on the back of your guided notes now. The mathematical definition of an or problem is what's called a union. It's meaning the union of those two pieces, meaning I'm joining those two parts together. Like this is the, okay, I want jeans or glasses type thing. You got people that just have jeans on, you bring them to me. I'm gonna make it a union. I'm gonna bring all the people with the jeans and then bring all the people with the glasses, and we're gonna put them all together. Okay. Now, how does that look on a graph? Well, this is how it's going to look on a graph. If I want any number less than 0 or greater than 10, that means I have this piece here or this piece here. I always think about it this way. Oars point out away from each other. I kind of think about it this way. They're like the oars on a boat. Like if this was my boat, whoa, that's a weird boat. This was my boat and I'm sitting in the middle of the boat here. These are my oars and I'm swinging them along to the sides. Okay, that's enough of my bad drawing. Now, ands, you kind of get a 2-for-1 deal. Ors, there's like, you have to do 2 problems within one, like this. How would I solve just this one on the left side? Well, I would subtract 8 from both sides, right? So t is greater than or equal to -1. And this one I would subtract 6. Okay, well, t is less than -4. Well, that just means that my answer is this here with both statements on there. How would I graph it? Well, let's go to our graph. I'll use this one, why not? I'm at -1 and -4. Okay, let's put -4 over here, -3, -2, -1, 0. Closed dot at -1, pointing to the right. Open dot at -4, pointing to the left. That's how we would draw that. Ors point out, ands point in. If you want to try this one on your own and pause and play when you're ready, go for it. So for this one, I would divide by 4 to both sides. So I have x is less than or equal to 5. This one I would divide by 3 to both sides. So x is greater than 7. Make sure you write the word or in there. It's not technically correct without the word or. And here we have, we'll go 4, 5, 6, and 7. Open circle on 7, pointing to the right. Closed circle on 5, pointing to the left. This shows, again, any number less than 5 or bigger than 7 would be a solution to this inequality. Okay, that's why we call them compound, multiple parts to them. All right, well, let's flip it around. Let's now give the graph and ask to write the inequality. Now, the first thing we have to decide is, okay, is this an and or an or? Well, since they point in toward one another, this is an and. Now, how do I write ands? X in the middle, 2 or equal to's. I put the smaller number on the left side. I put the bigger number on the right side. And then I have to decide, okay, do I have to turn those into our equals? No. Okay, so that's it. That's all we got to do. Yeah, that's all you got to do. Take a look at the next one. Now, for the or problems, and we know this is an or because they point out, I write the word or in the middle, and I write them as 2 separate inequalities, just like they're 2 separate pieces. X is greater than 2, greater than or equal to 2. And this is x is less than or equal to -3. There it is. Okay. We know we put the or equal to's because they are closed dots. I know this one points to the left, so this is a less than symbol. This one points to the right, so this is a greater than symbol. And we're done. All right, last one on there. Write each sentence as an inequality, and then we're going to graph. All right, a number x is greater than 8 and less than or equal to 4. Okay, now when it's an and inequality, I want to write it as one statement. So I put the less than or equal to 4 on the right side. Look, x is greater than -8. Read it backward here. There. X is greater than -8. So we got -8, open circle on the left side, +4 on the right side, connected in the middle. Ands go in. That's my answer there. And let's do this last one here. A number y is at most 0. So can it go over 0? No. At most 0. Greater than or equal to 0. Or at least y is at least less. I think I need to change this problem. A number is at most 0. Oh, I'm sorry. At most should be less than or equal to. I think I might have said less than. There we go. Is at most 0, so less than or equal to 0, or at least greater than or equal to 3/2. Okay, so remember that's just 1.5. Okay, forgot my at most at least thing. So y is less than or equal to 0, or greater than or equal to 1.5. If you wanted to leave it with the fraction in there, that's totally fine. The reason I'm putting it as a decimal so we can see where it goes. All right, now ors point out, so I'm going to graph this one separately. Closed dot at 0, going to the left. Closed dot at 1.5, going to the right. And there's my solution. All right. I hope we're having a good day today. Hope everybody's following directions, doing what they need to do, and not giving the sub a hard time. All right. See you later.